today I'm going to show you how to do the first problem in the Apply It for Topic B. So you guys have this worksheet and you should have this scatter plot open. To be clear, the scatter plot comes from Classroom. So when you go into Classroom, you'll see Unit B topic or Unit 3 topic B, Apply It, and you can go ahead and open that up and open up that document. So to start, you should read over this problem on your own, but a quick vocabulary check. What the problem is talking about is longevity and gestation time. So longevity is the typical lifespan of an animal, so how long it lives for. And then gestation is the typical time between conception and birth. And so before we really get started, I see that the data is over here. So that means a baboon has a gestation time of 187 days. So a baboon might be pregnant for 187 days. And then the longevity, so how long the baboon lives, is about 20 years. So a baboon's pregnant for about 187 days and it lives for 20 years. A cat, for example, has a gestation time of 63 days and it lives for about 12 years. Okay? So to start, it says the data for the 13 animals is listed on the spreadsheet. Create a scatter plot. Be sure the scatter plot fits in the yellow box, includes a title and labels, includes major and minor grid lines, and all 13 data points are visible. So I'm going to create a scatter plot. To do that, select all the data, insert, chart. I'm choosing the scatter plot. Go to customize. I like to have the label or the legend on the top. Longevity, years versus gestation time is good. I'm going to look at my horizontal axis. Gestation time in days, the label looks fine. I'm going to change my grid lines because 75 and 150 is really far away from me. So maybe let's just see what 7 looks like. 7 looks good, 50, 100, 150, 200. Maybe I'll put some grid lines in between so that it's 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. I'm going to go and do the same thing for my y-axis. So I need to go to vertical. Longevity in years is fine. I like 5, 10, 15, 20. Maybe I'll put some minor lines in between so that it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Insert, fit it into this box so you can pull it to make it larger, and looks great. B says, what is the linear regression model? The model should include real world variables, and I record it where it says B on the worksheet. So I see down here is where I'm going to record it. So in order to get the linear regression model, I need to go back and edit my graph. So here, advanced edit. And I'm going to scroll all the way to the bottom where it says trend line. I'm going to select linear. And then the label is going to be equation. That way I can actually see what the equation is. Update. I'm going to record that equation right here. So here we go. Now I can see it. Y equals 0.04 times x plus 6.648. Looks good to me. Notice that it does say we use real world variables, not x and y. So I'm going to replace x with what's on the x-axis, which is gestation time. Maybe I'll use a G for gestation time. And I'll replace the y with what's on the y-axis, which is longevity. And so L equals. Okay, looks good. C says provide an interpretation of the slope. So we need to provide an interpretation for the slope. So I'm going to start my sentence with considering the slope is 0.04. Because remember, the slope is always the coefficient of the input variable. And so now I need to go and do a little work. And so I'm going to make some notes over here for you. So this is 0.04 divided by 1, right? And so remember, slope is rise divided by run. But the rise is not actually rise. The rise is an increase in longevity. Increase in longevity, which is how many years? Which is in years, sorry. The run is actually a left to right movement, which is an increase in gestation time. Increase in gestation time. Note in days. So what we do when we talk about slope is we're always going to talk about the x variable first, and then we talk about the y. So considering the slope is 0.04 for each additional, which means increase, for each additional day of gestation time, an animal increases the longevity by 0.04 years. This is an example of what your sentence can say. Part C, no, that was C, so D, a mouse has a gestation time of 19 days. What's the predicted longevity of the mouse? So a mouse that has a gestation time of 19 days might live or have a longevity of, and so now that's when I need to go and do the math. So remember, longevity equals 0.04 times G plus 6.48. And so what I'm going to do is I'm going to substitute in 19 for G. So 19 is going to go right here. You're going to use a calculator to do that. I don't have a calculator to show you, so I'm just going to do the math in here. 0.04 times 19 plus 6.48, and that equals, oops, and that equals 7.24. So a mouse that has a gestation time of 19 days might have a longevity of 7.24 years. Next question. E, interpret the dog data point, which is 6112. So the coordinate is 61, 12. I'm going to remind myself that these cells are actually, this is x comma y, but instead of x, it's gestation time, comma, longevity. And so what this really means is, what animal are we talking about again? A dog. So a dog that has a gestation time of 61 days. So longevity lives for 12 years. And actually, I'm going to change lives to lived for 12 years because that's an actual thing that happened in the real world. Do you feel, oh, this doesn't say F, does it? Do you feel the linear model can be used to predict the longevity of an animal given the gestation time? So now I need to kind of generalize things. So do I feel like this model is good to predict things? So it said, a dog, for example, that lives 61 days lived for 12 years. So 61 days lived for 12 years is B right here. And so you make your guess based on what this is, where this is at. This is absolutely your decision. We're going to continue to develop this concept over time. I'm going to add one row at the bottom so that I can answer G. Last question. Juan's original question is there a relationship between mammals and longevity? So I believe that there is a relationship. I'd say that there's a positive linear relationship. So there is a positive linear relationship between gestation time and longevity. And over time, we're going to develop this answer